A very good morning to you, my dear students. This is your social studies teacher, Hassan Rashid. I hope you all are fine, and taking good care of yourselves. I wish you more joys and prosperity in the days to come. My dear students, this is the 7th successful week of e-learning program at Pakistan International School, Qatar. Today is our first class of social studies, for grade 6, in this week. We are starting the 4th lesson, measuring the weather. In today's class, we shall cover 2 topics, rain gauge and wind vane. Let's start our today's class. My dear students, today our study objectives are, to learn the importance of measuring the rainfall, to know the parts of a rain gauge, to learn the working of a rain gauge, to know the parts of a wind vane, to learn the working of a wind vane. My dear students, the first question that comes to mind is that, why is it so important to measure the amount of rainfall? Some possible reasons of measuring the rainfall can be as under. Water is a source of all life on Earth, so we need to know the pattern and amount of rainfall. Rainfall is a source of water for irrigation purposes, and irrigation engineers study rainfall and plan irrigation techniques accordingly. To predict amount of rainfall, and take precautionary measures in case of heavy downpour, to avoid damages. Measuring the rainfall can help predicting and better understanding the water cycle. A rain gauge is used to measure the amount of rainfall in an area. The amount of rainfall is expressed as depth of water in centimeters or inches, which fall on the level surface. Parts of a rain gauge include a funnel, a measuring cylinder, and an overflow jar. Winds, trees, surroundings, and improper placement of rain gauge affect the rain gauge, and can result in faulty or incorrect readings. The rain gauges cannot be put anywhere like some ordinary pots and objects. The standard placement of the rain gauge is that it should be placed 1 meter above the ground level, in an open area. If there are more rain gauges installed in an area, all the gauges should be of the same height. In a populated area, 2 to 4 times distance away from an object such as tree or a building. The distance should be according to the height of the tree or building. And in a forest, a clearing with the radius at least to tree height. Or place the rain gauge at the canopy level. A rain gauge measures the amount of rainfall that has fallen. It is basically a metal, plastic or a glass container, on top of which a funnel is placed. Inside the container, a glass cylinder, marked with millimeters, is placed. Rain falls on the funnel, and collects in the cylinder, where it is measured every day. The excess water overflows into the overflow jar. This is the picture of a standard rain gauge, where we can see all the 3 parts of a rain gauge: the funnel, the measuring cylinder, and the overflow jar. Let us now see a short video to better understand the working of a rain gauge.
Welcome to CocoRods, the community collaborative rain, hail, and snow network, where every drop counts, and where your school can report precipitation that helps out TV weather reporters. It's really easy, and it starts by checking your gauge first thing in the morning. So here's how the gauge works. There are 3 parts to the gauge. You've got the funnel, you've got the inner measuring tube, and you've got the outer cylinder. Truth be told, all you need is this outer cylinder to collect and measure precipitation. In fact, all you need is something where the top and the bottom are the exact same size, and the sides would be straight. So maybe even a coffee can could work. So think about it. Let's put our coffee can out at your schoolyard, and let's make it rain. And it's raining. Oh my gosh, that is actually a really good rainstorm. So how are we going to measure how deep this is? If you've got, let's again think that this is a coffee can in your backyard. How am I going to measure how deep this is? I want to know the depth in inches. Well, how about a ruler? I could just stick this ruler right in here and we could measure how much rain. So, looking at the ruler next to our gauge, we can take a guess on how much rain is in here. Maybe a ½ inch, maybe 3/4 of an inch. That's a pretty good guess, but you know what? I'm a scientist. I want to know how deep the water is in here with accuracy. In fact, I want to know down to the 1/100th of an inch. I want to take 1 inch and break it into 100 little spots, little parts. So that's where this measuring tube comes in. This is calibrated to the rain gauge to hold exactly 1 inch. If I've got 1 inch of water in here and pour it into the inner tube, it's going to fill it up all the way to the top where it says 1.00. So let's figure out how much we've got in here. We'll put the funnel on and pour our rain in. All right. And I can see we have 72/100ths of an inch, 0.72. That's great. So now the next question is, if we know how to measure rain with accuracy down to the 100th of an inch, fractions of an inch, what happens if it rains more than an inch? Well, let's see. What's happening? Yes, it is overflowing. So how are we going to measure more than an inch? Well, the inner tube, like I explained, fills up to exactly 1 inch. And so we could pour this first inch out. We'll want to write it down so you don't forget. And now we'll pour the remainder back into the inner tube. This rain gauge can actually hold over 11 inches of rain. So if you have that much rain, you probably have more things to worry about, maybe building a boat. So now we have 0.31 inches. Now what's the total for our big giant rainstorm? We already dumped out 1 inch plus the 0.31, so the total is 1.31. Next, you'd go to the CocoRa's website and report your data. It was that easy. If you have any questions, please contact education@cocorahs.org. That's education@cocorahs.org. And we'll help you get started by sending you a rain gauge and registering your school on our website. Real science helping real scientists. Your school can help.
A wind vane shows the direction of the wind. A wind vane has basically two parts: an arrow or a pointer, and directional signs to show the directions. A typical wind vane has a pointer in front and fins in back. When the wind is blowing, the wind vane points into the wind. For example, in a north wind, the wind vane points northward. A wind vane is the simplest weather measuring device. It is comprised of a metal arrow with a tail. It is mounted on a pole, or placed on a high building, so that it will turn around. The pointer of the wind vane points in the direction from which the wind is coming. It is important to note that the wind vane points to direction from which the wind is blowing. It does not point to the direction to which the wind is blowing. This is the picture of a typical wind vane. It shows the two basic parts, the arrow and the direction signs. In this picture, the arrow is pointing towards south. It means that the wind is blowing from south. Let us now see a short video to better understand the working of a wind vane.
Hi everyone. Today we're going to learn about how wind vanes work, and specifically what actually makes them point in the direction the wind is actually coming from. The first thing that we're going to discuss is that a wind vane, it points in the direction the wind is coming from, not in the direction that it is going. This is contrary to a windsock in that case. So now that we know that the wind is actually coming from the direction the wind vane points, we're going to actually discuss why the wind vane actually turns and points in that direction. So what you can see here from this diagram, in this case, is you can see that our wind is actually coming from the direction that the arrow is pointing here. So what is actually happening in this case then is that when the wind comes by, it'll actually catch on this big tail section that's very large, and it'll catch that section just like a sail on a sailboat then, and that will actually cause it to actually push around the corner and actually have the arrow point in the same direction that the wind is actually coming from. Thank you.
My dear students, with this we conclude today's lesson. I hope it was beneficial for you, and you learnt some new things. Feel free to consult your teachers to further clarify your concepts and questions. See you next time. Take care, Allah Hafiz.